Welcome to the Water Sciences Laboratory on the University of Nebraska East Campus. I am Dr. Saptashati Tanya Biswas, the Research Laboratory Manager here. We are a university research core facility, part of the Nebraska Water Center and the Doherty Water for Food Global Institute. The lab has been operating for over 30 years, specializing in analytical services and training to support university students, water researchers, and stakeholders. Whether you want to know what's in your water in Nebraska or in Nepal, we have the equipment and expertise for you. The lab has analyzed thousands of water, soil, and biological samples in support of water resource management and science. Ultimately, the lab helps to build a data-driven picture of Nebraska's water quality, identifies where remediation is needed, and equips the next generation to tackle those challenges. Our facility, which is right behind me, is around 4,000 square feet and houses over $3 million in high technology lab equipment. Let's visit our main sample preparation laboratory that also houses our standard method instruments. Many of these methods are used in research and monitoring projects such as the Nebraska Vadozone monitoring and the Know Your Well groundwater quality monitoring programs. This instrument is called an autoanalyzer and is used to measure concentrations of dissolved chemicals such as phosphate, nitrate, and ammonia. We run these tests on several thousand samples each year. The whole process is automated for rapid, precise, low-cost analysis. Chemical reagents are added automatically to samples and form uniquely colored complexes. The instrument measures the intensity or absorbance of the color to quantify how much is present. We use a similar chemistry in our flow injection autoanalyzer, also known as the latchet, for measuring nitrate and ammonia in soil extracts. This is one of our ion chromatographs where we use a column to separate and measure anions such as chloride, bromides, sulfate, fluorides in water and extracts. We also offer specialized methods. For example, we recently developed a method for measuring chloride and chlorination residues in spices such as black pepper and thyme. Most people don't realize that chlorination is used in water treatment for food production and that byproducts can be left behind after processing. This is the organic carbon analyzer and used for measuring total and dissolved organic carbon in water by persulfate oxidation method. The organic carbon in the acidified sample is oxidized to carbon dioxide and measured by the infrared detector. Organic carbon concentrations is a good way to measure water purity and safety. We have other instruments like the atomic absorption spectrophotometer that we use to measure cations in water like sodium, potassium, magnesium, and calcium. We will soon replace this AA with an ICP spectrophotometer that enables simultaneous analysis of a wider range of elements. We already have an advanced version for measuring very low concentrations of metal and other trace elements. This is the inductively coupled plasma mass spectrometer, or ICPMS, that is used for measuring very low concentrations of elements like arsenic, selenium, uranium, lead, cadmium, manganese, and so many others. The sample is aerosolized and introduced into the plasma chamber. This enables the ICPMS to measure the formation of charged ions through kinetic energy discrimination that removes interferences and makes it highly sensitive. The ICPMS can operate in tandem with another ion chromatograph system to analyze a variety of metal species. Additionally, we have developed a multi-residue method to measure polar pesticides such as glyphosate, which is the main chemical in Roundup pesticide. One of our core analytical service areas is environmental mass spectrometry. This technology measures a variety of pesticides like atrazine and newer chemicals like neonicotinoids, as well as human and veterinary, pharmaceutical, and other organic chemical pollutants. These advanced instruments are very sensitive and can quantify these chemicals at parts per trillion level, something not possible with other instruments. The two here are the liquid triple quadruple mass spectrometer and gas chromatograph mass spectrometer, each tailored to certain types of chemicals. Installed in 2019, the Xevo TQ by Waters is our latest instrument that is 1,000 times more sensitive than our older LCMS. This has doubled our throughput while increasing confidence in detection and accuracy of contaminants of emerging concern. Our final core analytical area is the stable isotope analysis. Stable isotope analysis measures isotopes of hydrogen, carbon, nitrogen, and oxygen at very high precision. Natural variations of the abundance of these isotopes can help discover the origin and flow of these elements in the environment. Stable isotope analysis often fingerprints sources of contaminants such as nitrate and can also be used in studying chemical reactions and metabolic processes. The Water Sciences Laboratory offers methods for stable isotope analysis of gases, water, and solids. The lab is well known for its methods for detection of isotopic composition of nitrate and ammonia nitrogen to support the investigation of nitrate contamination of groundwater and environmental fate and transportation. In the past few years, we have trained an average of 25 to 35 students and researchers annually. They all start in this facility. We offer several training modules on good housekeeping and laboratory practices, use of basic equipment such as analytical balances and micropipettes, sample preparation techniques, and advanced analytical methods involving instrumentation. The high quality results start with good laboratory practices. Maybe you would like to be a water scientist. I hope you have learned a little bit today about how we analyze the water around us to help students, researchers, and water professionals make decisions related to the incredibly important natural resource. I invite you to learn more about the lab and our services at watercenter.unl.edu/WSL. Thank you for joining me.